I'm Isabella.
I'm Laura.
I'm Miriam.
I'm Pram.
And I'm Tiana.
Manny, we're not hearing you. So hold off continuing.
Okay, so I'll
Okay.
be using Pram's computer as for my
That's fine.
phone.
Still-
Yeah, so sorry, we have two projects that we have worked on this summer. First one is looking at El Niño's impact on snowfall. So Laura and I have been looking at snowfall accumulation data and sea surface temperature anomalies and finding the correlation between those two, as well as hopefully being able to predict snowfall. How about you, Pram?
Yeah, our team is trying to visualize the relationship between malaria and climate variables in specifically Loreto, Peru. And the data set that we were provided with spans from 2009 to 2021. But let's hear a little bit more about the researchers, Manny.
So yeah, these are our researchers, Dr. William Pan, Dr. Sheneng Hu, and Dr. Mark Janko. They are the ones that provided the data, and they are also the ones that we've been making these dashboards for. So just shout out to you guys. Thank you so much, and thank you for this opportunity. Also, some general tools that both teams have been using. We have our DCC, Do Compute Cluster Open on Demand, which gives us the resources to actually make these visualizations. We're using Jupyter Notebooks and Python as our coding language, and then using GitLab as a sense of collaboration and how we presented our final deliverable in a Git repo. So yeah, Pram, if you want to carry on with the malaria team.
Absolutely. Thank you, Manny. So what is the significance of our project? Well, Loreto is home to the Amazon rainforest, which is a breeding ground for mosquito populations. And as a result, malaria has detrimentally affected Loreto's population and GDP on a larger scale compared to other areas, so Peru. Our team was tasked with designing a dashboard that'll help researchers track and predict malaria outbreaks, as well as show the relationship between malaria and different climate variables. So how do we do this? Well, to put it not simply like this, and I know this looks like a lot, so let's take it part by part and first take a look at how we handled the data. So the researchers gave us two main file types. We use pandas to read the CSV data, which you can see is the table above in the blue, and we use GeoPandas to read the shapefile. We combine these two files so that our visuals take all the information from one consolidated place. Let's look a little bit more into our data. Great. Our data is sorted by year, week, and district as specified by the UBI geocode, which all you need to know is it's a numerical representation of all the districts in Peru. And we're working with two types of malaria, falciparum and vivax, and approximately 30 climate variables we're taking into consideration. And while looking at all this data, we started brainstorming some ideas for a dashboard. So Isabel, could you tell us a little bit more about that?
This was kind of our initial design stage. This was before we'd really worked on making any of the visualizations ourselves. And a lot of our inspiration came from the World Health Organization and the Johns Hopkins COVID dashboard, which were given to us by the researchers as kind of examples. And as you can see, the main components are like a line plot and a map. And we can talk about the development of that in the next slide with Miriam.
Yeah, so to get started on these visualizations, as Isabel mentioned, one of the things we decided to include in our dashboard was a line plot because they're really great at showing patterns over the course of a year. And so if you look at the different iterations that the line plot went through, I started off with something that was really static, so you could only look at one district and 1 year at a time. However, our end result was very dynamic. So you could flip through different years, districts, variables, and you even had an average button where if you click it, it displays an average line so you can compare the current year's data to data from the previous years. Tiana, do you want to discuss your maps next?
Yes. So our first iteration of the map was static. It only showed one particular instance of the data frame. From there, we were able to add a widget, like a widget box and a map that interacted with the widget box. So when something changed with one of the widgets, the map would change the selection of the data frame it was taking from to reflect that change. And then finally, we then added 2 more maps, with one displaying the case data, one displaying climate data, and the last one displaying the health facilities in Loreto, Peru. And in addition, those widgets interact with both the climate and case map to show off some of the differences that are happening in each section of that data frame. So now let's talk a little more about our dashboard.
After working a little more on the visualizations, we kind of redesigned our dashboard to plan how these components would work together on a single dashboard, and you'll be able to see that on the next slide. As you can see, the main components of this are 2 maps and a line plot, and in addition, as we added this a little later, a widget box, which Tiana can tell us a little bit more about.
So with our widget box, this is like a complete version of it. The most important things to acknowledge from this are the lag, which climate events do not immediately result in malaria outbreaks. So our lag is between 0 and 24 weeks, to where if we're, say, at week 52 on the case data, you're able to go back all the way to a given number of weeks subtracted from that. Standard deviation is important because we're able to see outbreaks at the second standard deviation line. And lastly, epi weeks. The way that the CDC represents time is through epi weeks, but that does not line up to how we interpret weeks in a year. So what we did is, using the epi weeks package, we were able to show the start date and end date of a given week to have a better representation of what that epi week means to a user.
Yeah, so after making many edits to previous versions of our dashboard, this is what we came up with for our final dashboard. So we have 2 maps, 2 line plots, a widget box, and a hospital data map. And all 5 of these visuals have a really cool hover feature so that you can see like exactly which hospital you're looking at, or exactly which district, or how many cases occurred in a particular week. And as we mentioned before, this is a very dynamic dashboard, so you can flip through different years as well as different weeks. So those changes in weeks will mainly be displayed on the maps, not the line plots. And as Tiana discussed, we have a lag feature as well. So that lag feature only shows up in climate data. So the blue charts, the blue map, and the blue line plot. So that data is currently lagged by 7 weeks. And then, yeah, so you can flip through different districts. Those changes are reflected in the line plots. And then you can also switch variables. So the malaria variables are only reflected in those pink plots. So the pink map and the pink line plot. And then the climate variables are reflected in the blue plots. So that would be the blue map and the blue line plot. And last but not least, we discussed that average and standard deviation feature. So that black line is the average, the first gray shading is the first standard deviation, and the lighter gray shading is the second standard deviation. Okay. So now that we've discussed data handling and visualizations up until now, Isabel, do you want to walk us through what's next?
Sure. After a great next step for this project, if it were to continue, would be adding some of the predictive modeling aspects. The researchers gave us an R file that works on visualizing and predicting malaria in the future, and turning this into something that would be like understandable and visualized for the public would be a great addition to our dashboard. Not only that, converting our dashboard into a website so that it could be accessed by the public would be another great step. And now I'm going to pass it to Laura to talk about the Amazing Snowfall project.
Yeah, as we had mentioned earlier, we're working with the snowfall data set and then the sea surface temperature data set. So if you guys didn't know, sea surface temperature anomalies help us track events like El Nino, La Nina, which are just changes in the ocean currents. So since these events are very volatile, it's very important that we are tracking these anomalies and these events so we can predict weather patterns. Specifically, we are looking at the snowfall weather patterns. So we started this project looking at what these weather terms mean, what our researcher is doing, and made our first draft of our dashboard with a map and time series analysis. So then we started looking at the data. We are given a grid file for our snowfall data set, and then we have a net CDF for sea surface temperature. And these are just very common weather data formats. So to be able to look at this data and visualize it, we were exposed to X-arrays, which allow us to have labeled coordinates and have multiple indices.
as we started looking at this data, we realized we have a lot of data. We have almost 300 million rows of data, and this is just 1/3 of the snowfall data set. To kind of put this into perspective, if one row were 1 centimeter, this would add up to basically 1,500 miles long. That's kind of like driving from New York to Dallas. But as we started plotting this data, some of the packages we use HVplot as our plotting API. And then our researcher, Dr. Hu, had requested we add interactivity and customization to our dashboard. He kind of wanted his younger daughter to kind of play around with it and have fun with it. So we use HoloViews and Bokeh to add this interactivity. So with this, we made our first big step in our dashboard where we have our global overlay map with sea surface temperature on the ocean, snowfall on land, and then we have our global time series analysis showing the trends over the 22 years. And something interesting that we noticed is the anomalies on the bottom. You can see how it's increasing over the years, which is very interesting to look at, looking at the context of global warming. Manny, how do we continue from here?
So yeah, at this point, we met with our researcher, Dr. Hu, and he mentioned that he wanted to add an add and drag and select feature, so that we can basically look at specified areas for snowfall and sea surface. So for example, if I want to see the correlation between or look at the data from the US versus the North Pacific Atlantic, there has to be some sort of feature that can do that besides just looking at the global map. And so in order to do this, we used Rapids, NVIDIA Rapids, which converted our data from a CPU-based data frame like Pandas over to a GPU-based data frame like CUDA data frame. And this allowed our data to run efficiently on a dashboard. And so this is an example of the sea surface temperature dashboard. On the left, you can see that it's plotting all of our data. We have about 11,920,000. So it's a lot of data. And you can see the time series analysis on the bottom. And so to actually see the drag and select feature, you basically just drag and select, and that data will come down to about 260,000 data points that I selected, and the time series analysis would update on the bottom. And so with that, where do we go, Laura?
Yeah, so Dr. Hu loved our progress so far, and his main feedback was to include a scatter plot looking at the relationship between these two variables. So if we didn't have the scatter plot, if we were just looking at the time series of a specific part of the US, a specific part of the Pacific and Atlantic Ocean, we can see the cyclical nature of these trends, but it's very hard to tell from these graphs which one would be better at predicting this part of the US or which one has a stronger correlation. So that is the purpose of this scatter plot. So looking at these, we found that the Atlantic Ocean had a higher correlation than the Pacific Ocean. And one thing we also wanted to incorporate was a lag feature, just like the malaria team, since the effect of the sea surface temperature changing isn't immediately visible in the snowfall at that point. So we have a lag of 5 months right here. So looking at our final demo, we put this all together with our global overlay map. And you can slide through the years and the months to see how the sea surface temperature and the snowfall changes with that. And there's also a hover feature to show the data at that specific point. Then we have a global time series analysis where you can look at absolute or the anomalies, as I had mentioned, and then you can look at the different measurements for that snowfall. Then we have our interactive dashboards, just like Manny had mentioned, where we can select, for example, the US for snowfall, and we're looking at maybe around 2007 to 2017. And then same for sea surface temperature, looking at the Northern Pacific Ocean. And then you can see how the time series below changes with that. And then we can, once we select that, we can look at the glimpse of the data that we selected, and then look at a more in-depth version of this time series analysis, again, choosing between absolute anomalies and then different units for snowfall. And finally, we have our scatter plot. And one thing I want you to note when looking at this is with the lag, you can see how it changes from circles to lines, which is something that our team and Dr. Hu found very interesting. And we noticed this bimodal distribution and something that Dr. Hu would want to look more into. So again, when you change a lag, you can see how the correlation coefficient changes, and you can see which one may have a stronger correlation at what lag month. So Manny, how do we continue from here?
Yeah, so we made really big progress here, finding that correlation between the two areas. But our initial thought for the project was to be able to basically predict the snowfall. And so we didn't get to go into machine learning as much for these predictions, but we spent like about a week on it. And this is what we have so far. So we use RIMA models, which is autoregressive integrated moving averages. But in simple terminology in English, it's just looking at time series analysis and making those predictions. So the one on the left was our first attempt, which you can see did not do the best job. And then you can see on the right our SORIMO model. So the S stands for season or seasonal, which makes sense since our data has a sort of cyclical nature to it. And this did a lot better job at actually finding that, forecasting the snowfall and getting it right. And then on the bottom, we see the Holtz winter model, which just basically allowed us to predict the 2 years ahead of data that we don't have. And so, yeah, we also wanted to, in terms of moving forward, be able to put this on a public website, just like malaria's dashboard. Currently, they are in a Git repo as a final deliverable. But yeah, that would be one goal, reach goal for a future group that may be working on our data as well. And so to summarize, we both made 2 beautiful dashboards, I would say, that our researchers can use and they can explore their data with. And yeah, I'm very proud of us. So thank you so much. And if you have any questions, go ahead.